Welcome to the video where we are going to walk you through all of the different types of data types and all of the different ways you can utilize date, time, string, and numeric data using functions and all the different types of ways you can convert that data. We're just gonna, it's a lot of stuff that covers in this chapter, but I'm gonna kind of walk you through some pretty good comprehensive examples that will just show you all the variety of ways that you can manipulate your data using SQL. So to kind of cover the the main data types, we're going to talk about string, numeric, and date, or specifically even date time. In the book, it does talk a little bit about all these other types like large object data, and that would be something you'd store like movies and video files, or picture files. But we're going to focus just on string, number, and date. So don't worry about all these other types of data types in terms of like different standards of timestamps and different standards of currencies and different things like that. Let's just focus on numbers, strings, and dates, because that's going to cover basically everything you need to know. So as we go through this, we're going to use the dual table here just to kind of hard code in some data and show you what it can do. Now, if you know this by now, you know that 1975.5 is a number. And what we're doing here is converting it to a character, or converting it to some kind of string data format. Oracle doesn't care when you use the toChar, toNumber, or the toDate functions. It's not really specifying if we're converting this to a char or varchar or any of that kind of stuff. Or at least it may be putting it to a certain data type, but for the purposes of Oracle's functions, it's just trying to kind of explain that we're converting this number to a string. As we go further along, and I'll show you the cast function, we can actually specify that I want to convert this number to a varchar, or convert it to a char, or convert it to a number with a precision of 5. So we'll explain all that here in a second. But what we're done here is we've converted this number to a character. And if I were to go back here and just run, let's say, select this from dual, this would be the equivalent of actually pulling a number from an actual number. But this is taking that number and changing it to a string. The value of changing a number to a string is that when we want to format that number and add things like a $, or add other types of kind of formatting to it, we usually have to convert that number to a string so that we can actually manipulate it. We will keep things in a numeric format when we want to do math on it. So here's an example, right? We've converted this number 1975.5, but we converted it to a string so that we can actually format it to have decimals and padding and even a $. And just, if I were to go back here and subtract 1 from this, you'll get an error. And the reason why we're getting an error is that you cannot subtract 1 from a string, because a string is not a number. But if I were to go in here and let's say just take this whole thing away and say, can I subtract 1 from a number? You absolutely can do that, and you'll see here that it does. But once we've converted it to a string, you can't do math on it. So we're only converting numbers to strings when we want to format them. Now here's an example where we can convert a date to a character. Now this one looks a little confusing, and the reason why is that we're actually feeding in this date and time, but it's a string. So what we're doing is we're converting this string to a date, and then we're converting it back to a string so that we can format it a specific way. So if I convert this number here, it's actually converting it to a date, which will cut off the timestamp. And then it will convert it back to a string. So let's use a simpler example here. Let's just take this whole thing out, and let's just use something like the SYSDATE. Right? So I'll just select the SYSDATE, which will give me the current time and date, and let's run just this guy here. And you'll see here that we get, it's October 22nd, 2019 when I'm recording this. Now, if I wanted to, I could go in and add 1 to the SYSDATE, and it will add a day by default. I don't know if it's going to work when we do it like this, because sometimes Oracle is a little bit forgiving on this. If I go in and add 1 to this, yeah, it doesn't like that. And that's because we've converted this date to a character. And now that we've done that, we just cannot start adding things to it. So again, by doing this, what we're trying to do is we're trying to show you that we can change something. And so I'll even take this date out and I'll just change it to SYSDATE. And I'll run this here. We can take this SYSDATE and I can convert you know, a SYSDATE to a character. So let's take this guy away and let's throw one in here. We'll convert the SYSDATE to a character, and then we'll do it again, but this time we'll actually format the format of it. And this might help you better see. So now, by default, the SYSDATE kind of always shows as a date, but if you want to show the timestamp, it will do that. You'll see right here it's 11:02, and if I run this, my system date, it says 11:02. We can convert dates to characters, and when we convert them to characters, we can put them in specific formats, and we'll talk about this later, but we'll be able to, you know, if we wanted to take out, let's say, the seconds and just show the minutes, we can do that. We can really specify, you know, exactly what we're looking for here. I want to show just the month and the year. We can do that. And numbers can also, we can take strings and convert them to numbers. So here you have a string, and that string is an actual character value. We can't do math with it, but we can convert something that looks like a number to a number. So here's an example, right? We have this string of characters. It's this, you know, $1,975. If I were to take this actual amount and select it from the dual table, I will get a string, and that is a character, and that is because I know that because I can't add 1 to it. But if I go back here and I convert this string to a number, I'm able to do math with it now. And so now I can go and add 1 to it. So there might be a situation where you want to take a number and convert it to a string. On the opposite of that, there might be a situation where you want to go ahead and take a string and convert it to a number. When you convert a string to a number, you can sort it numerically. You can, you know, maybe you want to do math with that, and to do that, you'd again have to convert that to a number. Let me plug in my charger here real quick. Sorry about that. Okay. And then as we go further into you know, other date types, we have the date type. So again, what we're doing here is we're actually feeding in a string, and we know that it's a string because it has the ticks around it. If I were to just run this and just select the string April, you know, 15, April 14. If I tried to add 1 to it, it's going to say, hey, this isn't valid. You can't add 1 to a string. But if I convert this string to a date, and then I add 1 to it, I will be able to treat it like a date. So sometimes, you know, if people are storing information and you get information in a string format, you might want to convert that to a date. And, you know, again, what we had here is that, you know, if you have a string of data, we can convert that string of data to a date and then format it as a string so that we can, you know, go back and do manipulation of it. Don't get hung up on this toDate and toCar, because the main reason why we have to do this is that we're feeding in a string and then trying to convert it to a date. And then what we're doing is then once we have it as a date, we're showing you that we can convert a date to a character. So let's go a little further here and let's talk about this this cast function. The cast function is basically doing what these do up here. These are Oracle specific. The cast function is more of a standard, and when we talk about ANSI standard, you might hear me say the word ANSI standard a lot because SQL is an ANSI standard language. What that means is ANSI is the American National Standards Institute, and they're the ones who actually are a nonprofit that focus on creating what are the standard functions and commands that exist across certain types of softwares. They do other types of standardization, but one of the things that they will do is the cast function is an ANSI standard function. What that means is that it exists in most other SQL database, database management systems. So you should be able to go to something like DB2 or SQL Server or MySQL, and you shouldn't be forced to learn all these new functions to do some of the most basic things. Like if I want to convert a number to a date, I don't want to have to learn a different way to do it every time I go to a different database management system. So there are some functions that exist across all of them. And so what you have here is, we're pulling the invoice ID, date, and invoice total. We're pulling in the invoice date. This is casting that date as a varchar. And if you want to prove that, we can go ahead and add 1, and it will give us an error. And that's because you can't add 1 to a varchar. The invoice total, it's actually converting it to a date. Invoice total is converting it to a number. And even though it is already a number, it's just showing you again that the cast function is a pretty cool function that exists across all. And the format for that is simply just to say I want to cast. You would just add in the column and you would say as whatever data type you want to change it to. And most of these data types like varchar and number, they exist across all database management systems. So if I wanted to convert, let's say they've already done invoice date, we could, maybe we want to convert let's say invoice total. Actually, how about we do payment amount? I think that's one. Let's see. What is it? What's on this table that we know of? Let's go select. And I'm just doing this. This is how I would learn it myself, is I would just go start playing around with the cast function. So let's grab the, the payment total. That's what it's called. That's why I got it wrong. So I could go grab the invoice total. If I wanted to, I can go add, I can prove by adding 1 to the payment total. And you'll see here that I've got payment total plus 1. If I were to convert this to, let's say, a varchar. So I'm going to say cast it as a varchar. Length of 9, and then I'm going to close in my parentheses, and I'm going to call it as varchar payment. Let's run that, see what happens. There it is. Now you'll see that it's right aligned and the fact that it's left aligned shows you, this happens even in Excel, if it's right aligned, it apparently is a number, but to show that it's not a number, it's left aligning it. I don't remember the difference between left and right aligned. I just can tell that these data types are different based on their alignment. So if I go in here and add 1 to payment total, it has no problem. But if I go add 1 to payment total when it's a string, oh, that's funny. Sometimes Oracle can be forgiving. So the cast function here apparently is allowing us to add 1 to that. I think that if I were to cast this, I think the difference here is that if I had, let's say, formatted this with a $sign and put some symbols and characters in it, I think that's where you start to have problems. That's where, like up here, when I, when I ran this one up here and I had, when I have symbols involved here, if I add 1 to this, it doesn't work. Like I had this $sign symbol. So don't lose faith. But anyway, this is what, this is how you, as you start to learn this stuff, you start to experiment and play around with it. But the cast function, the reason I'm showing it to you now is that not that we'll use it in this class because we have the Oracle functions. The toChar, toDate, toNumber are very easy to use. But the good thing about them is when you get out there and you're, let's say you're at a company using SQL Server or MySQL, the cast function is a function that you will go and look up and use. And so a common thing is, I will go and I'll, Google things like how to, use toChar, function, but then I'll say in, SQL Server, right? And what you'll find is there'll be some kind of thing saying, all right, the toChar function in Oracle, it'll explain like how it works in Oracle. But then it'll probably say, in SQL Server, you need to use the convert function. Or it'll say, and as you go further down, it'll probably have, you can use the cast function. So you will have to kind of remember just generally, hey, we can convert data from one type to the other. Will you have to learn a whole new language? Not really. Like you'll just say, hey, how do I do this toChar thing in SQL Server? And they'll say, oh, well, in SQL Server, you can use the ANSI standard of cast, but SQL Server actually has its own, convert function that it uses. And so you'll have to kind of swap and, a lot of times I'm naming Oracle things and asking how I do it in SQL Server. Same thing. It's like, how do I do a minus statement in SQL Server? Well, this minus statement is an Oracle, keyword, doesn't exist in SQL Server, but there are ways you can do that same thing in SQL Server, and you can go out there and Google, and that's what Stack Overflow and a lot of Microsoft help or Oracle help will get you through, depending on what you're using. So when we are converting, numbers to characters, and we will only do that, or specifically we'll do that when we want to go through and format them in different formats. So here's an example where we're just taking the hard-coded value of 1975.5, but then as we do it, so here's an example, we take it and we convert it to a character and we don't do any formatting to it. Then we can go in and do all kinds of formatting. So we can specify a length by saying only show this as 999. If you ever have a number that is larger than the formatting allowed, in this case it'll just show hashtags. It does this in Excel too. When the number is too big and the column is too skinny, it just will show hashtags. In this case, if you format it with 4 digits, it will round it and show 4 digits. And this will just continue to show you, you can add in a comma if you want. I could take away a decimal if I wanted. If I ran this again, I would, let's see here, it will take away that decimal. If I add that decimal back, here it is with the decimal. So there's all these different types of formatting that you can do. You can go in and use US standards. There's there's all kinds of different formats. You do not have to memorize all of these, because if we ever asked you to go and use one of these formats, like US dollar, or there might be, let's see, if we scroll down here, you'll see there's like different types of accounting formats where it shows a plus if it's positive, it's a negative it's a not. There's just so many different types of formatting you can do. So you're not expected to memorize this. What you would be expected to do is know how to use the toChar function, and then to add some kind of mask. But to memorize all these types of masks, you're not expected to do that. So play around with this, take a number, select it from the dual table, convert it to a character, and then add in your own mask. Try decimals, try commas, try all kinds of stuff, and see what you come up with. When you are converting dates to a string for the sake of formatting, it's the same exact thing. You will be able to take a date and then add in a formatting string. Now, this is probably confusing, again, because what we're doing is we're feeding in a string and we're formatting it as a date. So what this is doing here is taking information and forcing it to be a date, so that we can then show you how a date can be converted to a string. So here's what I'm going to do. I'm actually going to take this part out, and I'm just going to add in the SYSDATE, because we know the SYSDATE is a date. And what I'll do is I'm just going to take this whole entire thing, and I'm going to go replace it everywhere in here that it says this. Just going to go replace it with SYSDATE for a second, because I think this will help us make better sense of this. Let's run this again. And of course, it's going to do that to me. Let's figure out why. I think the problem here is this right here. I added in a parentheses that I don't need. So toChar is always going to be the information you want to convert and then the mask you want to convert to. And here we go. So you know that I am running this right now at 11:16 on 10/22/2019. And as you go through this, you'll see this date is not showing any format. As I go through, I can put that in as a 2-digit year. I can put it in as a rounded 2-digit year. If I want, by the way, I can go in and change the second one here. Let's go run it. Let's make it a 4-digit year. We can make it a, add in slashes. We can add in, a long month with lowercase or a long month with uppercase. That's the difference here. So we've added in slashes on this one here. Here we converted it to year, month, day. Here we actually added in a day, which dy will add in the day. If I add in a long day, I believe that is the, if I remember correctly, yep, that's the one that gives me the long day. If I go back and just do dy, it will give me the short day. So anything you can imagine, right? D, month, day, comma, whatever you want to do. If you want to add in a 4-digit year and a long day and an uppercase, month, you can do whatever you want. So the possibilities are endless. If you want to add in a BC here, which basically will say if the date was before, or after 0, it will show that. So again, just like the, ways to format numbers, there's an infinite number of masks that you can put in. But you remember, it's toChar, parentheses, the date you're trying to convert to a car, and then the mask that you want to apply to that date. Here is just showing you another set of examples where, this is going to give me an error. Here we're just showing you another set of examples where we can go through and we can actually take a date and we can format the date to a timestamp. So right now, if it's 11:18 and I run this and I say convert it to just hours and minutes, or 24 hours and minutes. So if it's a 24-hour clock and it was afternoon, we would see it show up as 13 or 14. I can add in an AM or a PM, or I can add in a.8, AM, PM here. So what we see here is I can add in seconds. I can even add in, I believe it's milliseconds somewhere in here. Where does it get to do that? Let's see. I think it's FF is the millisecond. Now let's see here. I'll have to play around with that. If I go back to the book, let me actually pull it up real quick. While I'm doing it. Milliseconds are going to be, let's see here. We have dates. Yeah, FF4. So let's try that again. Let's do FF4. This date format's not recognized. It could be because the millisecond is not captured in this. But if I go back and run this, I'll just show you. And by the way, I really don't care about milliseconds. I was just trying to show you that you could kind of continue to play around with it. Let's just take like this one here. If I want to take the seconds out, you'll see right here it takes the seconds out. If I wanted to actually just show you the hour, right, I can do that. Am I always going to be like, am I going to be using milliseconds? It just depends. Like if you really care about milliseconds, seconds is, detailed enough for me. So we'll have to play around with this. What I believe is either the SYSDATE doesn't have a millisecond and it's only capturing a second, which I don't think is the case, or I'm just messing up the mask. And again, when I'm testing y'all over this, I'm not going to get that granular or make you memorize all these masks. I just want you to be able to reference in the book and go to the formats where you can look up that. And I think actually, let me try one more thing. FF4. Yeah, it's not working. And I'm kind of referencing the book here. But as I go through, you know, I could also even do it like little fun things like this, where I could say, look, it's Tuesday, 11, you know, I could add in a day, you know, and that would format this as Tuesday. So infinite number of masks you can use here, and you can apply them to numbers, you can apply them to dates, and you can apply them to date times. All right. So the next example we want to walk you through here is to kind of show you how you can take these different strings that you have now. Either you've converted a date, time, or number to a string, or you've used a string and you want to manipulate that string. So there are a lot of different functions in here that we want to show you. And there's some pretty cool things you can do. So for example, if you have a value where you have, let's say, spaces on one side. This is common in you know, when people are utilizing databases, that sometimes you might get these extra spaces. So if you wanted to, like, say, trim the spaces on the left, that's what L trim would do. If you want to trim the spaces on the right, that's what right trim would do. The trim would remove all, you know, leading spaces on the front and back end of the data. It's not going to take out the space in the middle. If you want to, let's say, remove a specific part of the left side, if you knew that everything here had a $0, you could say, hey, just trim that whole piece from the left side of the number. And in this scenario, if you say, hey, I just want to remove the $, you know, trim $sign from this. So, you know, really cool, you know, ways to manipulate that. And mostly the way you're going to honestly learn this stuff out in the real world is that you're going to be Googling it, and you're going to be looking up, like, how do I remove leading spaces, or how do I remove specific characters from this part of a string. So you'll learn how to parse and use functions or string functions, and learn how to Google Smart so that you can pull what you want to pull from it. In this scenario, it's padding it with a specific symbol. So in this LPAD example, this LPAD 1, it actually is going to pad to the left side 15 spaces. So it makes this whole character 15 spaces, and including this amount here. So it basically, even though it's only 5 characters, it's going to add 10 spaces to the right. In this scenario, it's going to add, you know, whatever is left over. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it says I'm going to make this 15 long. So it added 7 spaces here to the left. You can also say, if you can add in a third, you know, argument here, and you can say, I want to make this 15 spaces, but I want to pad it with a period. And that would add in, you know, 1, 2, 3, 4, 5, 6, 7 periods instead of 7 spaces. Here you can also do the same thing. You can right pad something, so you can add spaces to the right, or you can add periods to the right. And these last functions are actually, you know, not so crazy to get your head around. It's just saying, hey, if you have an uppercase, I want to make it lowercase. If I want to make something that's lowercase, I want to make it uppercase. This is a very valuable function when you are having data. For example, let's say you had 2 cities. One was the let's say we had Austin in this example, and then we had another situation where it was Austin. Now, the problem with that is that if you say, I want to know where the city equals Austin, it will show up only the ones that have uppercase A's. But if you say it equals Austin and there was a value that's Austin, it's not going to work. So what we could do is, the lower and the upper function are really great, because what you can do is you can unify it. So depending on whether or not it's Austin or it's just Austin, right? In this scenario, you could simply just say, hey, convert everything to lowercase. That way it would pull both values. So that's how upper and lower can be pretty helpful. And then the init cap, this one's kind of cool because what you can do is if you want to just do a capitalization of the initial letters of something and then uncapitalize everything else, this is kind of a cool thing you can do. So there's, without having to go through and grab the first character, uppercase it, and then lowercase everything else, the init cap function just goes through and says, hey, just do a capitalization on the initial word of every, unique kind of set of characters. Pretty cool. There are some other functions here, like the NVL, which I'm going to go over in a later part of this video. The substring and instring, I'll actually kind of touch on really quickly, but show you how they can be used very powerfully together. So the substring is basically saying, I want to take a string of values, and starting at the specific character, I want to grab the next however many characters. So you'll see here, when you start at the first character and grab the first 5 characters, this is what you get back. If I start at the 1, 2, this is 1, 2, 3, 4, 5, 6, 7, and I grab the next 3 characters, that's what you're going to get back here. If for this example, if I say go start at 1, 2, 3, 4, 5, 6, 7, so, or let's do that. We know that this is 7 actually. 1, 2, 3, 4, 5, 6, 7. If I say start at 7, but I don't specify a length, then it's going to go grab everything that remains in the substring. This is really valuable when you want to start doing some formatting of complex things like phone numbers, and we'll show you an example here in a second. The end string is really cool because what this will do is you feed in a string value and you say, tell me what character this specific character is going to show up in. So what this is saying is, all right, go look at this string and tell me what character the space is at. So if you go 1, 2, 3, 4, 5, 6, what it's telling you here is that the space is occurring at space 6. If I say dash, that means it's occurring at 1, 2, 3, 4. Now, where this can be really powerful is, let's say you want to go through and you want to remove these dashes, or you want to, let's say, maybe you want to parse out a first and last name. You don't know where the first name and the last name are going to start and end, or let's say you don't know where the last name is going to start necessarily. You know where the first name will start, but you don't know where that space is going to be. So you could say, hey, go pull everything up to the space where the character where the space is occurring, and then pull everything behind it. And I'll show you what we mean by that. Length also is a pretty powerful function. You've already used it probably if we played around in SQL, but it's a pretty powerful function that basically just returns the length of a string, and that can be really powerful. The replace function is also very powerful too, because you can just kind of go through and say, anywhere I see a certain value, I want to replace it with something else, and that can be pretty cool if you want to remove dashes like this one does, or you want to add a period where there's a dash. So here's a cool example where we actually are using the substring function to kind of parse through and format some data. So what we're doing is we're pulling the vendor's name, we're pulling the vendor contact's first name, but what we're doing here is if I have a last name as well, and what we're doing is we're going to concatenate the first name with the first character of the last name, and then we're going to concatenate that with a period. And so we know that we're concatenating with the first character because it's going to start at the first character of the last name, and it's only going to grab one letter. And if we run this, it's going to give us the first name, space, right, because here's the space, the first character of the last name, right here, concatenated with a period. And this is a nice way to format that data. What substring here is also doing is it's grabbing the vendor phone, and it's starting at the 7th character. And if I were just to go grab the vendor phone and run this, you'll see that the vendor phone has a specific format. So what it's doing is we're just cutting off the area code because it's all the same. And so we're just returning a phone number. So we're starting at that 7 character and saying give us everything. And oddly enough, actually, the reason why they're all 599 is that it's actually doing a where clause. So I could take this out and show you what it's going to do. You'll see here we got different phone numbers like 800s and stuff like that. And, you know, it's grabbing the phones just fine. It's showing us like all the people based on, you know, all phone numbers. But if I wanted to go through and say, hey, let's filter out and only pull me where the vendor phone number, starting at the 2nd character, so that would be right here, and grab those first 3 characters, it's only going to filter down to the ones that have an area code of 559. And it has to use the substring to do that. So pretty cool. Let me show you one last one where this is, I think, a very powerful way to learn how to parse. And this will also show you why the heck we want to subdivide our data to its most useful elements. So if you look at this, I have a name. I have a first name and a last name. In this situation, Lisbeth, the space, her first name is 7 characters. Lance is 5 characters. You know, Darnell is 7 characters. Jean is, you know, it's 4 characters. And so if we were to split this into a first and last name, and we assume that the last name will be everything after the very first space, that would be really hard to figure out where we parse it, because we can't parse it all in the same character. I can't parse it at the 7th, because if I do that, I'll grab Lance space P. So what we can do is we can say, okay, go grab the name and start at the very first position. And this is just for the first name. And for the very first position, we want you to go and grab the character where the space starts and subtract 1. So let's think about that for a second. If you look at the name, the space is saying, okay, we have 1, 2, 3, 4, 5, 6, 7. The space here starts at character 8. So what we're telling them is if we do 8 minus 1, and we feed that into the substring, it's saying go grab the name starting at the first position and go grab the first 7 characters of this column. And that's how it's going to grab Lisbeth in a second here when we run this. Now, for the next one, it's going to go and grab the name, start at the first character, and it's going to go find where that space actually starts, and it's going to be the 6th character. So it's going to go LANCE, and the space is here. But 6 minus 1 is going to help us go and grab the first 5 characters of this name. So let's just run this for a second and see what happens. So you'll see here, and if you want, I can just add this in as well. Let's go grab name. If you see here, what it's doing is we're able to parse out these names using the in string to dynamically figure out where the space is so that we know where the first set of characters ends. For the last name, what it's doing is it's saying go grab name and start at the space where start where the character equals, so what character is the space at? So in this one, it would be Lisbeth. It's 1, 2, 3, 4, 5, 6, 7, 8. But for the last name, it actually starts at the 9th character. So what we're doing here, let's say you didn't think to do that. Let's say you just went through and said, all right, I'm going to use this in-string function, and you ran this. You get something like this, and it'd be like, hey, this is weird. You know, why is it grabbing more than I need? You know, it's got this space here. And what you don't notice here is there's actually a leading space right after this this Lance. So maybe you wouldn't notice it here, but you definitely can see it here. And so if we go through and we add one, meaning let's go start at the next character up, you'll see that it fixes that problem. And so that's why the -1 and +1 have to be added. And if you didn't think to do that, you would have probably done what I just did, and you would have gotten something like this. It would have been weird, and you would have just kept sitting here tweaking it until you got it to pull exactly what you want. Even if you would have been like, all right, let's subtract 1, you're like, oh, that's definitely not what I want. So then you go the opposite way, and you all of a sudden realize, you know, you realize what's happening. So this is a really cool way to do it. But this also, again, reminds us that If we had just subdivided this to begin with, it's a lot easier to select first name, concatenate to last name. If we didn't do that, we have to get really complicated here. And how do we parse this data out? So this is all the reason. This goes back to our normalization days. Why do we subdivide data into its most useful form? So that we don't have to write stuff like this. Although I kind of enjoy writing stuff like that, but I'm just a geek. All right, so let's talk about if there is a case that you want to sort data that is a character data. So let's take this string example. There is a string here. This is actually a string, and so is this. So the ID is not a number that we're used to. And if you need to have some assurance of that, let's go to the string table, sample, and you'll see here that the ID is a varchar and the name is a varchar. So what that means is that if I were to go and let's say order by ID, what's going to happen is because it's a character, it's going to sort this like A, B, 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 C, D. You know, it's going to sort it like characters. And it's not going to sort it like a number because as far as it's concerned, these things aren't, this isn't bigger than that number and this isn't bigger than that number. These are, or this isn't smaller than this number, I mean. So what we can do though is if we convert that ID using our toNumber to a number, then it will actually sort like a number. The other way you could go about doing this is that you could go and select using LPAD, right? So we could pad the second character with a 0. So we could basically force this ID to be 2 characters and pad it on the left side with a 0. If we were to do that, we would actually end up with something that looks like this. And then if we decided that we want to sort by the LPAD ID, which is the column alias we've given it here, it will actually sort this in the right way. So, I mean, you can sort a string if you force in some characters to basically, you know, make it sortable. So if you add in this 0, 0, 0, I mean, if you even like go and create folders on your computer, if you ever created a folder called 1 and created another one called 11, it's going to actually sort those folders like characters. But if you add in 0, 1 and, you know, like we're doing here, it's going to sort them, you know, appropriately, like they would be numbers. So depending on the way you think, if you want to keep them as characters and not convert them to numbers, you can sort them like numbers by adding in, you know, a leading character, or you could just convert it to a number and sort it as a number. So when you're working with numeric data, there are really a whole bunch of different functions you can use. If you've ever used Excel, some things like the round function are not going to be new to you, but there's a whole lot of different functions, and I'm just going to breeze over some of them. So the rounding function, if you don't specify, when you have a number here and you don't specify what decimal to round it to, it's going to round it to a whole number. So that's what it's doing here. It's rounding to 12.5 to 13. If you do actually specify a 0, that's the same as not specifying anything at all. So if I wanted to just go in here and make a duplicate of this and not specify anything, we'll just look at these first few. We'll get the exact same result. We'll get a 12 and a 12 because that's what it's doing. It's rounding this down to the nearest whole number. We go back here and let's run this again. Here we've rounded it to the first decimal. Here we've rounded it to a second decimal, which is odd to me. Huh, that is fascinating. I would expect this to show up as, oh, I think it's because when it rounds it to a second decimal, it's just going to round this up to a 5. Let's do this. Let's make this a 4 point. Ah, that makes sense. Okay. So yeah, if I rounded it to the second decimal and then, you know, then what we'll see here is because it's 4.99, it just rounds this to the second decimal and it's rounding it up to 0.50. So rounding is a great function. The trunc, if you, let's say you don't want to have these considered in the calculation. So trunc, what we will do is it will truncate anything from the decimal and over to the right. So if you look at trunc 1, it actually takes the decimals off. If I truncate everything except the first decimal, it will actually give me 12.4. If I truncate everything but these two, it will give me 12.49. So this isn't going to round. This is a way to say, like, hey, I don't want to round up or down. I want to basically take the hard-coded, like whatever, grab these values here and then remove everything else. In this scenario, if you actually have decimals, you can actually truncate in the reverse way. You can say, hey, I want to truncate. If you have numbers to the left of the decimal and you want to truncate those, you can do that. You can say, hey, I want to get rid of these. So let's say if we truncated just 1, it should give me 1260, because what it's doing is it's truncating this number and getting rid of it. I can't think of a scenario when I'd want to use this, but that's not to say that it's not valuable. So again, if you can truncate to the left, you can truncate to the right, or you can truncate to the left. Ceiling, floor, these are basically just taking the number that you have, and it's looking for the number, the whole number that is above it. So if you add in a 1.25, it's going to return that as a 2. If you have a negative number, it's going to go to what is the number right above that, and that is a -1. If a floor, what that's going to tell you is the value right below, the whole value that is right below this number. So in this, it will be 1. In this case, the number directly below it is a -2. So, if you find yourself, in a situation, you're like, hey, I just want this to round down to the nearest whole number, or, how do I get this, to, drop to the nearest whole value? You could, start Googling, you'll find the ceiling or the floor functions. The absolute value, this is basically going through and it's going to, sorry, one second, make sure I'm saying this right. I'm going to check the book first because I want to make sure I'm going to say this, I want to say it wrong. So the abs is going to return, the absolute value of a number. I just want to make sure of that. So in this scenario, what that's going to do is no matter if it's a negative or a positive, it's always going to return the absolute value. So this is kind of redundant because the absolute value of 1.25 is 1.25. This, it just removes the negative. And the sign function is, will return a -1 if the number is less than 0. It will turn a 0 if the number is equal to 0, and it's going to return 1 if it's greater than 0. So what this is showing you simply is, is this number a positive or a negative? That's a pretty cool, function because, you might just want to know, like, if it's negative without having to, just return a value just to say, hey, tell me if it's negative, show a -1. If it's a positive, show a +1. And this could be useful when you're wanting to do some kind of like, logic based on if it's positive or negative. The mod function, I want to show you this one, and then the rest of these, I'm just, the power function, by the way, it's just going to do 2 to the power of 2 and 2 to the power of 2.5. So if I run this, that's what it's doing. So I'm not going to spend a lot of time. Fun fact, by the way, 2 to the power of 20, if you ever just wanted to know this, what is the power 2 to the power of 20? It's this number right here. And if you've ever seen that number before, that's the number of rows that Excel has. It's 1,048,576. Because when they built Excel, they built it to contain 2 to the 20th power. It used to only hold 2 to the 16th power. And I know this is completely random sidetrack, and it used to only hold 65,536 rows. So when they went to 2 to the 20th and being able to hold over 1 million rows, it was pretty huge. Square root, again, it will hand you the square root of a number that you feed in. Mod is pretty cool because what it does is it takes a value and it divides by another value and tells you what the remainder of it is. So 10 divided by 10, the remainder is 0. 10 divided by 9, the remainder is 1. Where I've used mod the most is I like to take a number and divide by 2. And if that number returns a remainder of 1, I know it's an odd number. If it returns a remainder of 0, I know that it's an even number. So no matter what the number is, if it's 1, 1, 1, 1, 1, or it's 1, 1, 1, 1, 1, 1, 1, 2, if I run this, I know that this first number is odd because the remainder is 1. I know the second number is even because the remainder is 0. So that's where mod can be very valuable. So when we talk about floating decimals, what's important is just to make sure you understand that when you have long numbers like this 0.999999, when you're doing averages or when values are stored like this does not equal 1, this does not equal 1. So the easiest way to show you this is if I were to kind of show you these values, if I run this query here, let's think about what's going to happen. Take a guess. The float value equals 1. So here's where the float value equals 1. How many am I going to get back? Did you say 1? That's right, because there's only one value that actually equals 1. Now, if I were to do let's say, float value between 0.9999 or 0.99 and 1, or is it 1.01? Now, is it 1.01? Is this number here between that number? Well, if you round it, you know that it is, and so yeah, it will pull that. So sometimes when you're going through and looking for close values, let's say you want to grab a value that's close to 1, you might have to use something like a between to kind of capture just the 100th decimal on top and below it. You can also go and use the rounding function and just round things to the nearest 2 decimals. And so what we'll do here is we're saying, hey, go round this float value to the nearest decimal, and where this rounded value equals 0. So let's go back and look at this for a second. So if I run this and I say 0, but what if I were to round this? So let's do this. Let's go grab the float value. Actually, we'll do it right here. We'll do it on this one here. Float value. Let's grab and let's grab float value. We're going to round it. And for this one, I'm going to round it to the nearest whole number. So I'll just do that. And then for the sake of these other ones, let's just see what happens here. Round to the nearest decimal, round to the nearest decimal. Oh, forgot my comma. All right, let's run this and see what happens. So here, if I round it to the nearest whole value, it's going to round these to 1. If I round this to the nearest decimal, you'll see that it actually returns a whole value. And if I round this to the nearest decimal, again, what it's doing is it's actually going to round me to the nearest value. And float values, when you are using a float value, they're a little different because they are not like a number. They're more like a decimal, and they're called something called a binary double. We're not using them in this class, but I'm just showing you that like when you end up running into them, they round differently than numbers. But the whole point of really showing you this is that when you have some value like, for example, 0.99999, if it's stored as a float, then or a binary double value, it's not gonna see that as 1. And so that's how you might have to handle these values when you have these long decimals. Now, if this was a number, it would have sorted it would have rounded it differently. But it's just kind of giving you an example of what the book is talking about. So there are some really cool things that you can do with dates. So we're going to grab some hard-coded dates in here and some SYSDATE. And we've already used the toChar function to show you how you can edit. The other thing you can do is you can take a date and you can round it. And what that does is, let's say the SYSDATE here is 10/22 at 11:50, and we want to round this date. It will actually go and round it down because I'm not halfway through the day. If I got to 12:01 p.m., it would round this to the next date. But what it does is it rounds it down to midnight of today. And midnight is the start of today. At midnight, at 12:01 a.m., it's we're progressing today. Noon is the middle of the day. 11:59 and 59 seconds is the last part of the day. What trunc will do is basically remove a timestamp. So this is rounding it down. Trunc, just like the number trunc, will actually cut off this timestamp. So you see here I have a timestamp. It's 11:49, but when I truncate, it will actually cut that time off and just round it down to midnight. Months between is a pretty powerful function, because what we can do is we can actually take two dates and say, give me the months between date 1 and date 2, and it will actually give me the number of months between these two dates. Now, September 1st and August 1st is actually going to be 1 month. But if I were to grab September 15th and August 1st, that's not a full month, and that's why you're getting this weird decimal down here returned of a 1.45. So that's what months between is doing, is it's taking two dates and kind of subtracting them and telling you the number of months. If you want to add months to a date, in this scenario, if I wanted to add months to August 19th, 2014, and I could say I want to take away a month, you'll notice here that down below is that it actually returns July 19th, 2014. We could also go in here and we could add 11 months, and what it does is then adds 11 months to that date, and that's why it gives us July 19th, 2015. The last day, or the last day function, if you feed in a specific date, it will tell you the last day of the month for that month, which is what it does here. It tells us February 28th. The next day function will always tell us, you can specify when's the next Friday after this date. So in this one, if it's August 14th, the next date for that date would have, that's a Friday, would have been August 22nd. In this case, if it's the next Thursday, it's going to return that as well. And then just showing you this example here, what this is actually doing is it's showing you that you can take a date and subtract the date. So August 19th, 2014 is after January 1st, 2014. If I were to subtract this is a bigger number, and subtract this, so I'd have to convert them to a date, because this is a string. But if I took this bigger number and subtracted it, or this later date, and subtracted it from this earlier date, I should get a positive number, which I do. It's 230 days between these two dates. If I take something like January 1st and subtract a later date, this is a smaller number than this number. It's actually going to give you the opposite. It's going to give you a negative number. Now, just to help you understand date calculations a little bit better, let's do something really simple. If today is the October 22nd, if I subtract 1 from the SYSDATE, I should get October 21st. If I add 7, I should get October 29th. If I add 365, you would think that I would get October 22nd, 2020, but I don't, because we have to take into account leap years. And so next year there will be a leap year, and that means that there's going to be an extra day in 2020. And so I would actually have to add 366, and that would get me to the right date. But so you're not ever going to know that. And if you've ever thought about, well, how will I handle, if I wanted to add 4 years, you think, well, do I add 365.25 times 4? You could do that, right? But you don't know if that's actually going to work. And so what you could do is just add 12 months. Or if I were to add 4 years, I could just say I want to go add 48 months. And so yeah, you don't want to get into this habit of doing calculations like this. But yeah, if I want to add in 12 months to today's date, it should be October 22nd, 2020. That's a year from today. But if I add 365, it's not going to take into account leap years. So as you play around with calculating dates, ages, things like that, you will use a lot of these cool date functions to understand how to kind of calculate and get math from dates. So when you're searching for dates that have timestamps, the one thing to keep in mind here is that dates with timestamps are a little different than just a date without a timestamp. So you'll notice here in this data here, I've got a couple of dates and they have no timestamps. So this is being treated as March 1st, 1979 at midnight. So this is literally at the turn of the day at midnight. And if you go back up here and think about this, a day starts at midnight. As it progresses, you go through 6 a.m. to 12 p.m. to 6 p.m. to 11:59. As soon as you have crossed 11:59 and 59 seconds, it immediately starts the next day. And that next day will start at 12 a.m. So if I tell you, February 28th, 2005 at 10 a.m., that's actually going to be probably right around, here somewhere. So if I said, hey, give me everything that is greater than February 28th, it would give me everything from here. If I did everything less than February 28th, it's going to give me everything south of this. So let's take a look here. Like February 28th, 2006. So here's the date. Now let's run this. If I say where it's equal to February 28th, 2006. Now I run this, I get nothing back. And that's because I'm not actually landing on February 28th, 2006, which is when it's without specified a timestamp, it's midnight. So what we mean is this, if it was midnight, it would show up here just fine. So let's do this. Let's say everything that's greater than February 28th, 2006. So that means everything after midnight of that date, but it's less than March 1st, which is going to be everything south of midnight on March 1st. So if I run that, are we going to get back both of these because you have less than March 1st? We probably shouldn't, because March 1st at 9 a.m. is way out here. So let's run this and see what we get. Yeah, we only get one date back. And if I were to go and let's say I want to look up where February 28th, 2006 shows up, but I want to just ignore this, we could always use that trunc function that we talked about to truncate the timestamp. And what that would simply do is it would ignore this, and then this actually equals to would work, because it's not looking at that timestamp anymore. And it basically makes it effectively February 28th, 2006 at midnight. So if it's a date without a timestamp, it's basically by default that date at midnight. If it's a date with a timestamp, then that means it is somewhere effectively in here, and it is not at midnight. So if you were to play around with timestamps, you'll see here it's the same exact thing. We can run this date sample if I wanted to and say, hey, return everything where the timestamp equals 10. Now, this one's a little confusing because what you're actually expecting is that it will return this date here, because if I converted this here to a date and formatted it as this, you would think, well, is it going to pull back the start date? The problem is that it doesn't actually have a date in here, so it's just looking at the timestamp, and so therefore it's not actually returning anything. Let's see. I'm gonna try one thing here. Let's do one thing. Let's try selecting from Google. So you'll see here that what it actually did is it defaulted, oddly enough, to the first of the month. of where I'm at. So it converted and took this, and it's a little odd, but basically when we run this, it's not going to it's not truncating the date off and only looking at the timestamp. But what we can do is we could take something like this, and we could convert the start date that we have here and convert everything to have a timestamp. So converting things to a timestamp, and so there's no formatted, there's no day, whatever. We're not like formatting the day, month, year like here, right? This would, what we're saying is, let's just take all the start dates and format them in hours, minutes, and seconds. And now, give me all of the date time. Give me all of the start dates where the timestamp is equal to this converted date. Formatted as a timestamp is equal to this. And that's why we get back that one example that had a timestamp of 10. This guy right here. So a couple other examples here is that if you wanted to say, give me all of the timestamps where the start date converted to 9 a.m. is so it's greater than 9 a.m. but less than 12:59. This is 12:59 p.m. It's not so it's not a.m. So it's going to pull me everything that is between those two timestamps. So this is between that. This is between that. So it should get back 2 dates. Let's see, or 2 dates. Let's see if it does. It doesn't, and I think the reason why is because it's the same thing that confuses me here, is that when we are taking this and converting it to a date, it does not compute to, it's not truncating that date. So the way to actually do this is the way it would work, is that we're going to pull back everything. So we're going to pull from the date sample, we're going to take all the start dates and convert them to this date frame format, and then we can use them in the filter. This is taking just a time and converting it to a date, and that's not going to work. Again, this is a complex situation. I would say that don't worry if you, the best way to get your head around it is to kind of go back and look at the examples and run them yourselves. All right, in this last piece of the video, thanks for sticking with me this long if you've kind of gone through this, because we're going to talk about how we handle logical outputs. So one of the common things that you may be used to if you've played around with other languages is something called a case statement. And you can use case statements in SQL, and they can be pretty powerful when you want to, based on a value, show different results. So if I run this query here, you'll see that I get an invoice number and a terms. And basically we can set our own value. So this whole thing is going to compute as a column value. You'll notice that there's no commas or anything. So basically what's happening is we're going to say, all right, in this third column, we're going to have we're going to look at the terms ID. And if we're focusing on just one specific column, we will say, all right, let's go do a case based on the terms ID. And when the value is 1, then set it to show, in this column, show net due 10 days. The next one is if the value is 2, it's going to set this column equal to this. Now, the one thing that you might be tempted to do is to say when terms ID equals 1. That is not part of the syntax. That's already implied when you said we're doing a case based on terms ID. So it's already saying, okay, we're looking at this when the value is 1. So we don't have to say equals 1 or when it equals this. That one took me a little bit to kind of get my head around because it already knows and it's implying. And so it says when it's 2, excuse me, when it's 4, when it's 5, and so you'll notice here, if we want to, we can go order by, terms ID just to kind of get this to show up a little bit better. So you'll notice here, anywhere it's 1, if it's 2, if it's 3, or it's 4, or it's 6, it's 5, sorry. And that's how this case statement works. Now, the key here is that the case statement only works like this when you are evaluating it based on a value in a single column. But there might be a situation where you want to kind of look at more than just a single value or a column. And so you can run a case statement that says, all right, when something is greater than this, then show this. Or you can use an operator. So in this case, we wouldn't go in here and say, all right, we're doing it a case based on the invoice due date. And the reason why is that we're not looking at just the invoice due date. We're actually taking another date minus the invoice due date and comparing that to this other number. So it's more complex than just saying look at this column and if it equals this value. We're putting in some conditionals here. So in that case, you actually create a case, you don't specify the column, and you say, all right, when this minus the invoice due date is greater than 30, show this. When this minus this due date is greater than 0, say that it's 1 to 30. And then there is this else statement that says, and if it's anything else, just show the word current. And then you will end as, and this is giving the when we end the case statement, we will end the case statement, and then we give that whole case statement. This whole entire thing is the logic to get the value. This gives it a column alias. So here we say we're ending the case statement. We're going to return the invoice number, total, date, and due date. We're going to put all of it here, and we're going to give it a column alias of status. And so sure enough, we have status, and it does the calculation. So if I did 20 minus June 19th, that will actually get me a number greater than 30. If I took, let's say, July 20th minus June 24th, that actually is less than 30. And here you have one where if it's anything else, like in this situation, the invoice due date minus so it's this minus the invoice due date, it actually shows current. So case statements are pretty powerful. They're a little complex to write when you're first writing them. Just keep in mind that if you're just looking at a single value of a single column, or the value of a single column, you don't need to they aren't that complex. You don't have to use operators. You just need to specify the column you're evaluating. But if you are evaluating across multiple columns, or you need to use operators, then you don't specify the case column that you're working on. So in this case, let's talk about how we would handle nulls. So you might have already run into this before, where we were trying to play around and figure out what do we do if a value returns as null? Can we show it as something else? So in this case, what we're doing is that we're pulling the payment date and the invoice date, and then what we're going to do is we're going to look and evaluate the payment date. Now, if the payment date in COALESCE, this exists across other database management systems, so you won't just use it in Oracle. But let's say that you have a situation where you want to go and you see that you have a payment date of null here. Can we have it return some other type of value? So let's call this payment date 2. So what we're going to do is we're going to look at the payment date, and we're going to look at the invoice date, and basically if the payment date is not null, we're just going to want it to return the payment date. If the payment date is null, it's going to go and return, in the next situation, it's going to return what to do if this is null. If this is null, it's going to return what to return next if that's null. So let's say if this is null, the invoice date here is June 30th. It's going to return June 30th instead. So the third thing here, and you can add in as many expressions as you want, is what happens if this is null and this is null. If it will continue to go indefinitely until it will return the value you want. So what this is simply doing is saying, hey, if the payment date is not, if it's null, return invoice date. So in this case, it's going to return the payment date because the payment date is not null. But in this case here, the payment date is null. So therefore, in this third column, it's actually returning the invoice date. Now, let's say the invoice due date was null. The problem is there's a constraint on this table that doesn't allow the invoice due date to be null. But what would happen here is that the payment date was null and the invoice date was null. What we would have seen is that it would have returned a date of January 1st, 1900. The data doesn't allow to show that, and I was just playing around trying to figure that out. But that's what happens here. So I could keep adding to this indefinitely as many times as I want. The NVL function, which I'm not as big a fan of because it only focuses on what to do if something is null, but I'm going to show it to you anyway. So basically it's saying, all right, if you have a situation where it's going to look at the payment date and it's going to evaluate the payment date, it's going to say, all right, if the payment date is not null, then just show it. But if the payment date is null, here's what you want to do if it's not null. If it is null, right? So what NVL is doing is only evaluating what to do if it's null. But it doesn't tell you what to do in the opposite case. Like what if you wanted to show something else besides the payment date? So if this payment date is not null, it's just going to show the payment date. But what if you wanted to say, okay, evaluate two different options? You're saying, okay, look at the payment date. If it's and let's run this here real quickly. So it's saying, all right, look at the payment date. If the payment date is not null, what do we do? And it's gonna say this is what you do if it's not null. The second operator is telling you what to do if it is. So it's a little different because it's adding in this, in this scenario, we're saying, all right, look at this date. And if the date is not null, just show the date. Show this. Otherwise, if it is null, show unpaid. In this scenario, it adds in an extra, flavor to it, and it says, all right, if this is not null, don't show the payment date, actually show this. Otherwise, if it's null, show this. And pretty valuable, useful function. A lot of times when you have something like this, you want to show it in another way and call it out. So that's a very cool function. And honestly, you can use the NVL to do kind of the same things as these others. In fact, this NVL, you could probably do the same thing with a COALESCE. If you wanted to play around with it, we could go in here and let's just try it for a second. Let's say, all right, we're gonna do the COALESCE of the payment date. And if payment date is null, we're gonna show unpaid. Let's, maybe we need to convert this to a car. Yeah. So it's basically doing the same thing logically. So you don't have to worry about learning both. You can pick the one that you like, play around with it. And the last thing we want to cover here in this video is just row numbers and ranking. So if you have a situation where you want to force in a row number, so not just the row nums that are on the pseudo column, but you actually want to have a row number that we can pull from. Once you do this, you can actually force in a non-pseudo column, and you can actually go and make it a like a subquery, and then you can do some really cool stuff with it. So now I can actually go in and say, where the row number equals 5. And I can start to do some really neat stuff with the row number. So what the row number does is it hard codes in a, it says, I want to select a row number, and you say over what column we're going to be putting it in. So it's saying I want to order by a certain column, and then we're going to give it a column alias of row number. So if I run this again, what it's doing is it's going to sort by vendor name, and then it's going to give me a row number based on that sort. If I wanted to, I could actually put in a descending sort, and it would give me a row number. And I can't refer to the row number. I can't go in here and say where row number, because this is still a column alias, so I can't use it like that. But you could define it as its own kind of subtable and make it and select from it like a subquery, and then you could actually use the row number in your where clause. So in this one here, it's actually adding in this partition, and what that's going to do is we can go in and we can sort, we can order by the vendor name, but then we can actually partition by the vendor state. And so what we're going to do is we're going to actually break it up. So we're going to sort by vendor name within each state, and then we'll give each a row number. And so this will give you kind of a row number for each grouping. And the last one I want to show you here is the rank and dense rank. The only difference here is that it's very much like the row number function syntax. It's just that ranking, what it will do is it doesn't, it takes into account ties. So in this scenario, if we're looking at, let's say we're ordering by invoice total and we do a rank over the sorted invoice total, what this is doing is it's saying, all right, these first three here, these three values, they are all ranked first. But then the next two values, they're going to be ranked fourth, and that's because it's taking into account that 1, 2, 3 different records before it were ranked were ranked high above it. So it doesn't. So it and this is where I think people who went to high school and today, understand ranking better than I do and how that all works. I don't know if we do dense rank or regular ranking. But if you do a dense rank, what that's going to do is say, all right, if you have a tie for first, for the first three people, the next person that's out here, they are considered second place, right? So, they are ranked second. So, it depends on, the situation and your business logic, if you need to use a rank or dense rank, but that's how you would use these. And they're very much like using the row number partition and the row number order syntax. We're going to stop there, and we will leave that to you. If you have any questions, let us know on the discussion board. And thanks for watching.